Hey, okay, welcome here, lab number 12. This is the Spectra lab, and it's actually the last lab, at least you'll turn in for a grade. I say that because in place of tomorrow's lab, we're going to do the same thing for test 3 that we did for 1 and 2, and that is after you guys take the test, I will work through the test, make a video of that, load it onto YouTube, and send it out. And so, like I said in the lecture hall, I'm going to try to give you that as soon as possible. And I'm thinking that's probably around 3 o'clock if everything goes well. And as I was mentioning, nothing's going well today. Everything's falling apart with this building. But they've cleaned up this building, this room quite a bit. I actually already sent the lecture material out to you, and in that email I mentioned that you're going to get the lecture first because I thought that was best, that you guys get started with the test coming up. And there's some interruptions we're going to have working here, plus there's some other filming we have to do. So this might be late in the day before this video actually gets to you, and that's fine though, because this is not due until Wednesday at midnight. In fact, I should have said that in the lecture hall, that I put on Canvas all of your homeworks and all of your labs that are due here for test number 3. Oh, it looks like they're doing some more work, but I think we're okay. We'll just keep going until they kick us out of here. Or turn off the power on us again. But we'll just, I just set up Canvas so that you don't have to turn in this particular lab until Wednesday at midnight. And so knowing that you probably are focusing more on the test 3 and the final, I thought that'd be a good place to start. So I'll say it again, last lab, lab number 12, other than tomorrow, which is kind of a lab, but you don't have anything to turn in, is to go over the test and kind of grade yourself and also learn along the process. So if there's anything you missed on test 3, you won't miss it again on the final exam if the question, happens to be closely the same. Because a lot of the questions are closely the same on the final exam. Some are some other ones that we just didn't have enough space to ask you about. But a lot of them are a lot the same. They're not exactly the same, but they're the same logic. So if you missed it on test 3, hopefully you will catch it on the final exam. The same thing can be said about test 1 and test 2, but I'm going to assume you've already seen those solution videos. If not, they're a good studying way to get ready for the final. All right, so turn to page 93. This is where it talks about the spectra, and maybe more importantly, turn to page 94. This is what you're going to be turning in. And as a last lecture, I like to tell the students this is really a fun one because you're going to see some really pretty colors. Now, being online here, I don't know how the pretty colors will come out, but we'll try to film them and we'll see how it works. But let me draw a little picture here on the board, because one of the things that hopefully you got in the lecture on the chapters 17 and 18 is that the visible spectrum, what we call the colors, the Roy G. Biv, and I'm going to put them backwards for a reason you'll see here in just a second. This is your color spectrum. And again, what I hope you got out of the lecture was your human eyes have the ability to see and detect different wavelengths / different frequencies. And so we learned that the red was the low frequencies or the high wavelengths, and the violet is the high frequencies or the low or small wavelengths. And so it's normal to list from small to big, and our equipment is set up to measure wavelengths. So that's why we're going to put violet on this end, low, and go to high. And in fact, this thing right here is called a spectrometer, because the way it works is light comes in this opening through a series of optics. It projects it on a little screen, and to the left as you look in the screen you will see a number of 400, and on the right you will see 700. Actually, it goes a little higher than that. And it would look something like this. And so this side is the eyepiece. In a face-to-face setting, I would say, okay, when you get your chance, what you're going to do is you're going to look in here and you're going to see the screen. And obviously right now you can't see that. But what I'm going to hopefully do is, after I kind of film all of this, I'll then get the camera and put the camera in this eyepiece and see what pictures we can take. And so we will splice together these pictures with the video, or maybe we'll have to scan it with some video. So we know that's going to be a little more work for us. And so between that and the fact that the building has some troubles today with the water pipe leak, we just know this might take a little bit longer. So I'll say it again. That's why I really wanted to make sure I sent off those videos to you so you can get started with the lecture material and get ready for the test and focus your attention on that. And if you have enough time to do the lab, that would be great too. But make sure you're ready for the exam first. All right. So, like I said, this little piece of equipment called a spectroscope takes the light that comes in and projects each of the different wavelengths at different parts on the screen. And so the idea is that you will begin to recognize that if your little light source has any light that is in this area, your eyes will detect it as violet, and the equipment will measure it in the realm of 400. Of course, in the middle here is about 550. And so if our little light source has 550, and I guess I should have put the units here, nanometers, 700 nanometers. This is the wavelength of the light. And so if our little light source, and we're going to look at a bunch of different light source, has any wavelengths at this value, it will project it at to this spot. And not only that, your brain will call it green. And some of these colors are really vibrant, and that's why I said it's really too bad this one we're not here face to face. In fact, this is the one I was kind of struggling with and kind of deciding, should I or should I not set this up. Hey, more workers. Okay. All right. I think we're okay. We'll keep going. Yeah, I think she's going upstairs. All right.
She not get in.
No. She was saying hi. She was going on. All right. So, yeah, don't pause it. Don't pause it. All right. So, what I want to do here is to hook up all these different light sources and then go ahead and look at them. And then, of course, like I said, I'll kind of run through, we're looking at them, but later on I'll take the camera and shine it in here. So here's what we're going to do. The lab is really kind of an easy setting. I like to tell the students this: look in the spectroscope and just draw what you see. And hopefully you will begin to recognize that if your light source has any wavelengths in this area, not only will it put it on the screen at 550, but your eyes will see it as green. Likewise, if your light source has any of the violet, you will see it in this area in the 400s, and your brain, of course, will see it as a violet. And if your light source has any of the red, you will see it in this part of the screen, and you will see it in your brain as red. So this will hopefully convince you, and we'll see how well this comes out online, but red are in this area. That's your brain telling you what the wavelength is, not just the equipment. Greens are in this area. Okay, and so your brain can tell you 550 by giving you a color green. It doesn't have a scale on it. And your brain can tell you what violets and blues are. And so these are the list of the different light sources. And I believe there's 11 of them. Let me just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. However, The first one, sunlight, we're going to skip. Partly because it's kind of hard to get out there, and then mostly because we've got the June gloom and we don't have some good sunlight right now anyways. But another important reason is the sunlight and the incandescent are pretty much the same. So I'm going to do the incandescent, and that often happens, especially in summer school in June with the June gloom. We don't get the direct sunlight, but that's why we always have the incandescent. So we can say incandescent is really identical to the sunlight, and what you will hopefully see first thing is the incandescent looks white and it gives off all of them. So I set this already up for the incandescent. Here's the incandescent bulb right in front of the light source. The plug is right here, so I'll plug it in now. And when I plug it in, hopefully, what you will see on the camera will look white to you. This is the camera registering white, meaning it has all the colors there. And when I look into the spectroscope, what do I see? And so what I see is color at every spot. And so what I mean here is draw what you see. We'll splice in a photograph in a few seconds here of this one. But in a regular setting, I would say come over here and grab some colored pencils. And so here's some violet ones, here's some light blue ones, here's some royal blue ones, here's some orange ones. Where's the royal blue? Okay, here's some orange, here's some red, here's some yellow, here's some green. And we just say put together a whole spectrum of colors. And if you see anything in this area, draw the color that you see. And so hopefully you will see always violet over here, and you will see only green over here, and you will see only red over here. But given that we're online, I know it might be unlikely that you have a whole set of colored pencils. But if you do, or if you have crayons, get a set of colors, get about 7 of them, use that phrase, Roy G. Biv, and find the red, orange, yellow, green, blue, indigo, and violet. And then draw what you see. For those of you, which is probably most of you, who don't have either colored pencils or crayons or markers, whatever, go ahead and just take a regular pen or pencil, doesn't really matter, and then draw kind of a little band of what you see, and then just label it. Oh, violet, and then a band. Oh, blue, oh, and a band. Oh, green, and a band. That's yellow. All right? And so you won't be able to draw in colors if you don't have colored pencils. But you can draw and then make divisions and say, okay, from here to here it looks green to me, and from here to here it looks blue to me, and from here to here it looks red to me. So that's kind of how we'll do it. And that's kind of what I was thinking. I almost skipped this lab thinking, I don't know how to do this one online. This is going to be the hardest one. But I go, you know what? I think we can. If we can somehow get the camera to get a good picture, and we can just draw it in and label it instead of the actual colors, I think it'll work. So that's the decision I decided to go with. Because again, I really want you to see these different colors. This really is a neat lab to wrap up a semester, because students usually get real excited about the colors. And so it may not be quite as exciting here online here. But here's what I'm going to do then. I am going to then look in here, and then of course we'll edit the video, and so I will put the photograph of what I see. And so I look in here, all right, so if you just looked at the photograph and now we're back, then I'll go ahead and say, hopefully what you saw is every color. And so in a certain range you saw red, and in a certain range you saw orange, and in a certain range you saw yellow. And so that's why we like to do the incandescent one, because the incandescent shows all of them. All right, well, let's do the other ones. And here's the short answer: draw what you see. So the next one says, use a red filter in front of the incandescent bulb. All right. So this is helpful for learning about what do you actually see? In fact, right now I'll just point it at the camera here. And so if I put this red filter up here, I'm hoping what you see through the camera is it looks very red. It's called a red filter because it really blocks everything but the reds. Although you'll be able to see when we put it through the spectroscope that it's kind of red and the oranges. We call it red, but it does let red and orange through. But it blocks things like the yellows and the greens and the blues and the indigos and the violets. So I'll go ahead and put the filter in front and look. And then this is where I'll splice in a photograph of you looking in here, and then you draw what you see. Okay. Now, I hope you saw the photograph, and I hope what you saw is you saw just these colors coming through. That's what we mean by the filter. The light itself gave off all the colors, but you only saw those because it filtered out the other ones. You'll see that again. Look at the next one. The next filter says use a cyan. Now, a cyan is a fancy word for a blue-green. So this is a cyan, this is a blue-green. If I put it in front of the incandescent bulb, I hope you can see through the camera that this looks kind of blues and greens. Of course, the blues and greens are kind of in the middle of the spectrum, so it's blocking out, in particularly the reds and the oranges and the yellows. And so if I come over here, and this is where we'll pretend you're looking in the spectroscope. And so I'm going to put the filter in front. I'm going to look in here. And your job is to draw what you see. And it looks like I see a bunch of blues and greens and even violets. Okay? But draw what you see. And so now I'll splice in the photograph. Okay, so if you then looked at that photograph, you'll see why we call it a cyan filter. You'll see that right here in these blues and the greens, maybe from here, but even a little bit of violet, this part goes through. But we've blocked what you often call the warm colors. So we've got the cool colors coming in and the warm colors are kind of left off there. And also, we've got the yellow filter is our next one. So the next one is to draw what you see. And again, it's kind of the same physics. We call it a yellow filter because what comes through is yellow. Now, it's not perfect yellow. In fact, this is kind of a light yellow, and that would tell me that it's letting in the oranges and the greens because they're right next to the yellow. And it probably is blocking the reds and the blues and the indigos and the...
Power failure.
All right, we back on? Oh, okay. And just for you students to know, yeah, we had the power go out again, and so anyway, so we were cut out in the middle. So we're back again. And if I remember right, from before the power went out, I was just putting this filter in front and getting you a chance to see the yellow. All right. At least without dividing it through the spectroscope. But a better picture is what you see through the spectroscope. And so I'll just kind of pretend like I'm in class. I'd put the yellow filter in front and look in here and say, okay, well, what do I see? And so I'll just hold it here. And then again, you're to draw what you see. And so I'll splice in right now the picture. Okay, so hopefully you looked at the picture of, you know, what do you see as the light comes through there. And so hopefully these are beginning to make sense to you, why we call them red filters and cyan filters and yellow filters, and you know how your eye only sees the light coming from you. And so you start with white light, which has all of them, and then these other ones may, you know, block certain things. Oh, Ron, will you check the sound just because, you know, the power came back on. I suppose we should make sure the sound's still working and all that. Okay. Now, the next one is kind of a fun one to do, and you could even make a good prediction on this. It says put the yellow and the cyan together. And so if you kind of take a look, you'll see that the cyan kind of let these go through, the blues and the greens right in here. And the yellow filter let the yellow, but also the neighboring ones like the green and the orange through, and even the red a little bit. But you see that. So if you put the two together, if you stack them together, after it goes through the first filter, let's say I set the cyan first, I will block everything but these two colors. And then the yellow would let these three, but these two are already blocked, so it'll let the green through, but not the blue. And so this is a good way of making a green filter. And so if I put this up here, just kind of looking at your drawing as well as looking through this filter, hopefully you'll see green. And that's the idea here. And so put the filters together, look inside, and say, okay, well, what do I see? And so this is a good place to then splice in a camera shot of the inside. Okay, well, I hope you looked then at this and then drawn on your page 49 what you see. And that's kind of the first half of the lab, where we start with a incandescent one that gives off all the colors, and then from there we filter out different ones. Now, another fun thing to show is that other light sources do not give off all the colors. They give off just certain ones. And so let me take this out of the way and make a light bulb that is made out of just pure, let me see, sodium. And so if you just take sodium and run electricity through it, it gives off a unique set of colors that are unique for sodium. In fact, hopefully what you will see as we look at sodium, helium, helium, neon, mercury, and then we'll go to the fluorescent bulb. But the next four are all elements. And you will see they give off a set of unique colors. We call this the fingerprint of them. And so you could actually tell what element you have by looking at the emission, the light that comes from it. In fact, if you've ever wondered why scientists know certain elements are on certain planets or on certain stars, it's because they're looking for these particular signature, these particular fingerprint, or you might even say DNA of those elements. Because, you know, as you know, the only planet, and now if that's not a planet, that humans have gone to is the moon. And we have sent rovers to Mars, but most of the time, to figure out what elements are there, we don't actually have something land there. We look at the colors that come from it. And the sun is a good example of that, because we know that there's a lot of like sodium in the sun. And we've never been able to land a spacecraft or humans on the sun, obviously. It's way too hot. But yeah, we can land at night, Ron says. But yeah, well, obviously he's joking. But that aside, we do that a lot. So in order to illustrate that, I have grabbed a sodium light. Now our sodium light takes a while to warm up, so I had plugged it in earlier. But you will probably notice just with your eyes, it looks very yellow, because the signature for sodium is quite unique. It is just yellow. And the yellow then, hey, well, welcome back. We have more like interruptions. And maybe I better go a little quick so we can do one final part of this. So I was right here talking about the sodium. Let me do the sodium for you. And so the sodium, and the short answer I can give you is draw what you see. So I'm going to look in here, and now I'll cut away to a still picture. All right, so hopefully you draw what you see. And you only see yellow. And so this is kind of a unique one because most of the elements give off at least a couple of different colors. This one only gives off yellow. So hopefully you drew just one line right about in here somewhere. Just yellow, about 590 nanometers. Well, since we need to get out of this room so they can continue with their work. Oh, we do got, okay. Let me just show you the other ones here. A fun one to see is helium. And so I'll turn it a little bit towards you. But here is a helium bulb. And so this has some helium gas inside of it. And so if I set it up here and turn it on, it kind of has this peach color to it. Let me get it a little bit closer to my spectroscope. But again, the answer is draw what you see. And hopefully what you get out of this lab is there's a unique set of colors. And there's 7 you can see for sure. You might be able to see as many as 9. And so if you kind of align this and take a good picture of it, you'll see 1, 2, 3, 4, 5, 6, 7. Yeah. And so there's 7 little stripes of different colors, and so I see some red and some red and some yellow, and so let me pause right here and cut away to a still picture. Okay, so I hope you looked at that picture, and where there were the colors, just draw little marks. And if you need to label it, just label it. If you have colored pencils, that's great. But that set of colors is unique for helium. No other elements give that off. In fact, the name helium is quite fascinating because it comes from the Greek god Helios. And the early scientists were studying the colors coming from the sun, and they realized that different elements had different colors. And so they go, oh, look, there's sodium. Oh, look, there's oxygen. Oh, look, there's carbon. And then they notice this pattern, and they go, wow, here's a pattern we've never seen on Earth before. And so they called it helium. They said there must be an element in that sun that is not on Earth. And so that's why they called it helium. Now, it turns out, later on, we discovered that there is helium on Earth, and so we have plenty of helium on Earth. It's actually not really until we started digging for coal and for oil, because that's where it gets trapped, because helium in the atmosphere kind of just escapes and it doesn't react with anything, so you can't find it in compounds with in the rocks. And so the only way you can find it is the stuff that's trapped in these clay mines or clay tops of the mines, in the same way natural gas is trapped. So we eventually figured out that there was helium, but I always find it very interesting, both the name and the fact that we actually discovered the element of helium in the sun before we discovered it here on Earth. And so that's what makes the name interesting. Well, let's go to the next one. The next one is neon. This is my favorite, if not my favorite of all of the elements, because this one gives off a lot of the warm colors. And so let me say, all right, well, we're back, and we had another fun interruption here, but I think we got rid of that static problem that started up there. And so I'll continue. And I think it got started here at about the neon, so I'll say it again. This is my neon. This is the one of my favorites. It's got the nice warm colors. You can see how bright it is. But it's also a fiery red. It's got the red colors in there. And so again, when you get a chance to look inside here, and so I'll kind of look inside here and say, ooh, wow. And so let me pause here, because this is a good place to cut away and let you look at a still picture. Okay, so hopefully you got a chance to see those different colors and then to draw your picture. And if you did, you'll see that there's a bunch in this area. There's a bunch of yellows and a bunch of oranges and a bunch of reds. And I can't remember, I think there might be a hair green. Yeah, there's just a hair green. That'll be interesting to see if that comes out on the photograph, because the green is actually kind of the warm gas inside here. I mean the warm glass. And so I don't think it's part of the neon itself. In fact, you see it sometimes in the sodium, you see the green. But anyways, it's the warm colors. And so again, the only thing I can say is draw what you see. And the point of this second half is to show you that the sodium and then the helium and now the neon, they all have their unique signature. They all have their unique set of colors. All right, well, let me move on to the last of the elements we can show you. And that is the mercury. And the mercury is in a little bit of a different setup. It's down here in this tube. And I put my filter on here. And so let me turn that one on. I'll even point it towards you guys there in the camera. And I'm hoping it looks kind of a blue-white. The blue is there because there's really strong amounts of blue coming from this. And so when you get a chance to look in the spectroscope, you'll see blue. But there's also some green and yellow. There's 3 lines. And when they mix together, it kind of gives it a white. It's not a true white. It's not a white that it's all the colors. But there's actually a lot of green here and a lot of blue. And that's just kind of your eyes mixing it all together here. Oh, okay. So the bulb's kind of loose, Ron was saying there, and so it kind of is going on and off. But right now it's on, so I'll keep going here and say, all right, let's look at what comes out of here. And there's, yeah, really bright blue, really more towards the violet or a royal blue, and then a green. And then just not as bright, but there's that yellow, and the 3 together give it that, like I said, kind of a whitish look, but again, not a true white. It does not look like the sun. In fact, it angles towards the blue because that blue just kind of stands out. But the green also can stand out. In fact, the green can really pop. Lucky Charms is the commercial company that really took advantage of this. They added a bunch of green on their cereal ones because most of your grocery stores have fluorescent lights, and the fluorescent lights have mercury in them, and the mercury gives off a lot of green. And so in a store, things can look really rich in their green color. And so as a marketing ploy, they made things extra green so that then they would reflect in the store and be extra green. And that was designed as a marketing gimmick to get, kids attracted to by the Lucky Charms cereal. But I'll look in here and then cut away to a photograph here. So I'll look in here, and now would be a good time to cut away to a photograph. And so now I'm back. And so now as I'm back, I hope you will see that you will be drawing a line over here in this kind of this royal blue violet area. Then there'll be a green one here, and there'll be a yellow one there. And the yellow one's kind of dim, so hopefully it'll come out into the photograph. Well, the very last one to do is really what I was saying about the fluorescent tubing. Remember, the fluorescent tubings have mercury in them. So to illustrate that, let's take a look at the light, the last one, coming from a fluorescent light source. And the best way I can do that in class, if I was in class, is just to take my spectroscope and point it right at the fluorescent lights and take a look. And when I do, boy, I really see that green that pops out. And so I see the green, and that is actually the green, the same place the same location as the mercury. This is kind of that story I was telling you about how the early scientists found the helium. It just, they knew there was something that was standing out that they'd never seen before, so they said that must be a new element. But they also knew what, say, oxygen looked like, and so when they looked at the sun and saw that same pattern, they go, oh, there's oxygen. There's also this mercury in the sun too. So when they look and they see that green and that yellow and that royal blue to violet area, maybe it's more violet than royal blue, it pops out. Now, in this picture, I see a little more beyond that. I see a turquoise and I see some red. So that tells me that there's mercury and other things in there. And sure enough, there's other things. But the point of putting it here was to give you a chance to look at the spectrum and to see how it overlaps with mercury and other things. So there must be mercury and other things in that fluorescent light. And so that would be a good time to cut away to a photograph. And so I'll pause. Go to a photograph. And then come back here and say, okay, now that you've looked at the photograph of the light coming from the fluorescent tubes, again, compare that to the mercury right above it, and you'll see that connection. So, again, big challenge today. Not only was it, I think, the hardest lab to try to get on camera, so I hope this works out really well. We still got a bunch of photographs to take, but given all the chaos going in our room right now, we have other crazy things going on. But we'll splice all this together, and I think we can make something good out of it. It just might take a few hours from now before you get it. So I'll say it again, if you have gotten those, because you should have already gotten the videos from the lecture today, work on those, because you have a test coming up tomorrow, and then you have a final exam on Wednesday. And these labs aren't due until Wednesday at midnight, so you have more time to finish up the lab. All right, I'll call it quits from here and go do some editing.